We know that if the bases on an exponential equation are equal, like here, 5 is equal to 5, then this means that the exponents should also be equal. So in this case, the two exponents, 3 and 4x plus 1, are equal to. So if we need to find the x, the only thing that we need to do is solve the linear equation that the exponents give us. 3 equals to 4x plus 1. And the result for x is equal to 1/2. Let's verify that using logarithms. Note that this is not necessary in any case, but let's see how we could verify the same problem using logarithms. So, if these two quantities, left and right of the equal sign, are equal, then I could get the logarithms of these two. And then the logarithms of them will be equal to. Why? Because simply, if two numbers are equal, their logarithms are equal under the same base. But using now the rules of exponents that tell us that I can bring the exponent and multiply it by the logarithm in both cases, then what I get is 3 times log with base 5 of 5 is equal to 4x plus 1, remember that you need to put this in parentheses, times log with base 5 of 5. But we also know that the log of a number on the same base of that number is equal to 1. So log of 5 with base 5 is equal to 1. So what I have is 3 equals to 4x plus 1. If I solve this equation, that is the same with the equation that I solved before, I have that x is equal to 1/2. So you can see that we can solve an exponential equation either using the fact that if the bases are equal, the exponents are equal, or by taking the logarithm from both sides. Note right here that if the bases are equal, like here, 5 and 5 on both sides, I do not need to use the logarithms. While if the bases were different, then in this case, the use of logarithm would be necessary. So what we are going to do now is look at a different example, and let's do it together, where the logarithms, the two bases of our exponential equation will be different. So let's take 5 to 3x equals to 3 to 4x minus 2. What we should pay attention to right here is that this base that I have on the left side of the equation is 5, and this base that I have on the right side of the equation is 3. So this means that since the bases are not equal, the exponents will not be equal either. How do I solve this type of equation? Well, the only way to do that is by taking a logarithm from both sides. If these two quantities are equal, then the logarithms of those two quantities will be equal too. Now the trick here is that I need to use as a base one of the two numbers, either 5 or 3. It doesn't matter which one I choose. Let me choose the number 5. So I take the logarithm of 5 to the 3x with base 5, and this is going to be equal to the logarithm of 3 to the 4x minus 2 with base 5. Pay attention to the bases of the logarithms. These bases, they need to be equal. So these two bases should be equal. It doesn't matter what number you choose, as long as you have the same number here. Now, I will use the rules of logarithms in order to bring the 3x, that is the exponent here, and the 4x minus 2, that is the exponent here, down and multiply it by the logarithm. So the rule tells me that if I have a log of x to the k, this is equal to k times log of x. And this is what I do. So I have 3x times the log with base 5 of 5 on the one side is equal to 4x minus 2 times the log with base 5 of 3. Now, log of 5 with base 5 is equal to 1. So this means that 3x is equal to 4x minus 2 of log with base 5 of 3. My goal here is to separate the variables from the constants. Note that the constants that I have are the number -2 and the log of 3 with base 5. I may not know exactly what the number is, but this is a specific number. So I have on the left side 3x, and on the right side I distribute and I have 3x times log with base 5 of 3 minus 2 times log with base 5 of 3. Now this is the constant of my equation because it contains only numbers, while this is a variable term. I need to separate the variable terms from the constant terms. So I push all the variable terms on the left side of my equation, and I keep the constant terms on the right side of the equation. Now, on this side, I have both variable terms. I can factor out the x, and inside my parentheses, I have 3 minus 4 log with base 5 of 3. This is equal to -2 log with base 5 of 3. I want you to pay attention to the fact that I don't need to do anything with this part right here. I may not know exactly what it is, but if I use a calculator, I'm able to calculate that. And then, at the next step, what I need to do is to consider the coefficient of x. And the coefficient of x in this case is this. So I will divide both sides with the coefficient of x, that is 3 minus 4 of log with base 5 of 3. I will simplify these two quantities, that they are at the numerator and the denominator, and my final answer is that the x is equal to -2 times log with base 5 of 3 divided by 3 minus 4 log with base 5 of 3. This is my final answer. Note that on the right side I only have numbers, which numbers I can calculate and find an approximation for the x.